here. Yeah, what this video is all about is to explain the assembly process of a basic flat pack cabinetry. Here you can see a couple of different designs. This is a fairly typical overhead unit. Of course, I can make them any size and shape. Getting the eBay store to reflect that's a bit tricky, but I'm working on that. Here is a typical base unit. Pretty featureless, no runners, no adjustable shelf rest holes, but you can see in its simplest form you have a floor, a cabinet end, another cabinet end, a back and a rail. Another name for these components, because they would be running in series if you have a few cabinets side by side. I'll just grab another one which we prepared earlier. In a run of kitchen cabinetry, you have a repetition of these uprights, which, for simplicity, they're also called blades, not just ends or cabinet sides. Now, I don't know whether this is very clear in this video, but maybe this way. You can see the design that I've got established here is the uprights, or the blades, are sitting on top of the cabinet floor. And that means that if there's an extension, an overhang, say from the kick frame, the load, if you have an overhang on the kick frame, the load on the cabinet is directly transferred to the base of the cabinet, so it's extremely strong. If this part ran past, you'd be relying on a very small percentage of the material on the far side of the job, on the far side of, say, a biscuit or a dowel or screws or nails or whatever you're going to use, to be holding that load, and that load would very easily just break the board out. So having the upright on top of the floor produces a lot better load bearing capacity. You see it's very minimal deflection with my body weight on it. And of course the back is on the same way. As you can see, the back is actually running past the blade, and that's again deliberate. The floor and the back are then the same length. The rail goes between the blades. So that's probably the easiest way of seeing it. Pretty sure that'll show up well in the video. Now I'll show you the overhead unit, and I'll explain why the back is put on rather than between the two uprights. It's a very similar structural property to the load bearing capacity of the floor. Okay, this overhead unit has got shelf rest holes drilled, of course. Now, here you see the top and the floor, which are identical parts, extend beyond the blades and are flush in length to the back of the cabinet. I don't know whether that shows up very well, I'll just check. Hopefully I won't shake you around too much. As you can see, oh, it's a bit vague. Okay, there's autofocus. I've used both, let's see if I can get that better, both brads and screws for structural strength. I'll just zoom out slightly. Unfortunate that I'm restricted for doing both jobs at once. I've used brads primarily to assemble it very quickly. I'll show you that process. And I've used secondarily some screws going through the back into the blade. Now that seems a little counterintuitive, but having the back between, again you've got the weak joint problem as I demonstrated with the floor of the cabinet. The tensile strength of the screw going in there, funny enough, is providing a better tensile load bearing capacity than the joint going with the back between. So I've opted for this design also, so the uprights are always butting into the rear of the cabinet, or the back of the cabinet, and always landing on top of the floor, and also consequently on the underside of the top of the shelf, or the top of the cabinet. Fairly simple structure. There is a lot to watch out for, but nothing sort of beyond the technology of most people. It's quite a simple process. You may notice, if I grab a sample, this is the thickness of the board, and as you can see, the screw is actually inward. It's probably a better example. It's actually inward of centre of that board, and there's a reason for that, and that is to preserve the strength of the outside edge of this panel. Better zoom out so you can see the rest of the details. I think I missed a whole lot of detail, so here we go. So I've used brads, which are not overly clear at this zoom level, and you've got screws as well, which are put inward from centre of that line. Yes, I suppose the best thing now is actually to assemble one. Okay, the parts of the cabinetry will come with a label similar to this. I've blacked out the customer's name, so for privacy reasons. So obviously the first line on the label is customer. The second line is a job number or name. In this case it's the kitchen. Then you've got in brackets the part number. In this case it's part number 6, and it's a drawer side. You can see 1/2, it means it's one part of 2. Obviously on a drawer you have 2 components, 2 drawer sides, and shorthand it's just drawer unit 1. The size of this component is 500mm by 254, so it's 500 left to right and 200 top to bottom in this case. And you've got 1 edge by 0 edge, so 1 edge is by 0 edges. That 1 edge being 500mm long, which is this top edge, and no other edges edged. Okay, now how that relates to the cutting list, you've got part number 6. I might actually just highlight that. Might run a highlighter through it. Underline it. Okay. Now you can see part number 6, of which there are 2. It's a drawer side. It's a drawer unit 1, which relates back to part number 6, drawer side, drawer unit 1. There are 2 of them, so there's 2 of them, and this happens to be the first one of the 2. Length being 500, width 254, and the first edge is the 500mm length is edged, and the other length is not edged. So it's only got the 1 edge, in this case the top edge, and no other edges edged. So that's how those 2 relate. So if you're looking at your cutting list, the label, that's your part number. It's the easiest way to find things, versus the part number which is on the left hand column. Part number 6 in this case, part number 6. Okay, that's pretty simple. Obviously if you have multiples of them, you'll have 1 of 2, 2 of 2, or if there's 50 of them, there'll be 1 of 50, 2 of 50, 3 of 50. So you're able to see how many parts you've got of that type, and you'll be able to check that you've got in fact, which part of that group you've got. Alright. There's one back. I think these are very similar in size, so it's a bit difficult to show. That's at the back. We have 2 blades. 2 double ends. Blades. The top on the floor. Now, the top and the floor are not important at the first stage of assembly. What is important is, if you remember the detail, that the cabinet ends, or the blades, sit on top of the floor, and so does the blade. So assembly is much more easily done by just assembling those 2 components I'm right-handed. If you're left-handed, you might do the opposite. Now, a little tip here. As a cabinet maker, use a nail gun sideways. On site, you tend to use more, the gun gets used more in a vertical fashion. So what I've done on this gun is, in a very garden variety manner, I've put a counterweight on there just so the gun is very easy on the wrist to use. If you have access to a brad gun, the assembly process is much faster. Now, the first thing I did was line up these two components by eye as well as I can. Put a lot of pressure on this part so that the brad wouldn't, when the brad went in, it wouldn't knock the cabinet around too much as we were assembling it. Now, I'm doing this fairly quickly because I'm familiar with it. The reason why I use the brads is obviously it's very, very fast, but there's another reason. It's much easier to line up than using a screw. If you are going to screw the cabinet together, you'd end up pre-drilling some screws, bearing in mind the thickness. I might actually draw a line there. The thickness of the component are 16 millimetres. Okay. Now, first thoughts that you'd want to put your screw starting point towards the centre of that component, but it's actually better to have it in and angled in an outward direction. So I don't know whether that shows very well, but maybe we'll grab a smaller part. So what I'm doing, in effect, is put that line there so you can see the position. Let's see how that works. See that? I'll zoom back out. Okay. So you can see the hole is significantly towards the inside edge of that line. But it is angled in an outward direction. I'll put the screw in there. I'll start the screw so you can see that. Focus. And that is quite deliberate. That's an outward direction. Where are we? Somewhere here should be focus. Focus. Oh, you can see the outward direction there. I'll turn that screw in. You'll see that the board I use is actually quite good quality. The trick now is, of course, to try and flush things up when you have, I've got a very small part which makes it doubly difficult. As the screw goes through the first part into the second, it's quite acceptable to drive straight through. The likelihood of the part being pushed to the side because of a hard particle in board, is very likely. But what we have here is the board hasn't split. It is quite a clean, solid and dense board. Many other boards that are in some of the other flat pack cabinets are not really such a robust and finely made material. Okay, that's my first sample. I'll do the real thing here. I'm just guessing the position of those screws. Most people will have a cordless drill at home, or a couple of them. Actually, I'll get the screw started. Of course, if you do start the screws before you put parts together, your hands are then free. If I refocused. We're still out of focus. Now, pre-drill those holes. What is important is you need to try and free up your hand to hold the part that you're about to attach. So I'll start the screws in the holes that I've drilled. So now my hands are free to hold the other component. So I guess if I turn this part around, you'll be able to see the whole lot going together. You may also at that angle be able to pick up the fact that the screws are angled outwardly. course today, something that I haven't mentioned is that it is really valuable to have a solid, a firm, flat bench to work on. Often when I'm assembling out on site, I'll assemble one of the cabinets, whatever will stand fairly well, and use that as my assembly bench. So if you're a bit low on flat hard surfaces, assemble one of your cabinets to give you something to work with. Now I'll switch back to using the brad gun and you'll see how much faster it is. Now perhaps if you decided to buy a fairly large number of components, it may actually be worthwhile buying a brad gun. It'll save you so much time on the assembly. As you saw how quick that was probably faster than doing the holes. And we've decided to get some bad weather here, by the sound of it. This being an overhead unit, it will require some extra reinforcement for being able to carry its weight by being hung on the wall. So for that purpose we will have to put some screws into the back, because the brads are very handy but they're not quite that good at bearing, you know, tensile load. Now what I did just then was actually put the first brad in. I fly along and do things without realising what I'm doing. The first brad was placed, then I squared the cabinet up so that the floor, or the top, whichever this is going to be, of the cabinet is then flush with the balance of the cabinet. So the items all squared up. At this point, the cabinet is basically symmetrical top to bottom, left to right. So it's arbitrary. Some other cabinet designs may not be so, depending on how they're drilled or how they're set up to be used. Now I naturally did something when I put the screws in, and that's what's made this thing asymmetrical. Towards the top of an overhead cabinet is where obviously the tensile load is when it's being fixed to the wall. Any load is pulling on the upper edge of the cabinet and is pressing on, so there's a compression on the lower part of the cabinet. So what I tend to do is kind of have a tapering spacing. Towards the bottom, just a screw, then probably about the halfway mark. It's not super critical, and getting closer and closer as you get to the top. And it doesn't matter that the screws are very close to the brad, I'm within about 15 millimetres, maybe half an inch. Screws. Hold the screw. Now, that's the back held to the cabinet so it can handle a load by the back being screwed to the wall from within. So that's quite strong. The top doesn't need any extra help because basically it's sitting on top of these components. The brads are very much strong enough to do that job. But the floor of the cabinet, if it's fixed to the wall, there's a tensile load on this joint from any load that's put within. Now if people put a lot of crockery or whatever in their overheads, you may want to reinforce it. I only generally put a couple of screws towards the front because to the rear of the cabinet there isn't much of a load possible. There we go. 2 screws. Now of course, turning screws in, again you probably do a tapering spacing there. screws that I actually intend to have up on the eBay side as well, they are a very high strength screw, and they have what's called a 4-in-1 drive. Basically, you can use a Phillips screwdriver, a posi drive screwdriver, and of course the special 4-in-1 tip. I might put the macro photos or something up on the video. See how we go. Okay, so that's that. One cabinet structurally sound, ready to be hung on the wall. So I'll just review that again. We have the screws placed in here, even though we've braided the cabinet together to increase the strength of the cabinet, for any load on the shelf. And again, there's sort of a higher density of screws towards the top here, because this will be under the tensile load if being fixed to the wall here. Again, the advantage, companies like IKEA give you a thin 3mm back and a tiny metal bracket, which is all well and good if you're fixing to, say, a masonry wall. But if you're fixing to a stud wall or anything where there's only narrow points of fixing, that can be very problematic. And that's why I've chosen to go with full thickness back. It is completely a structural part, so you can put a screw in anywhere. So if you've got spacing from studs, or if you have some other, I want to say, wholly or intermittent support, you can fix a screw anywhere you like. Obviously, you tend to stick towards the upper end of the cabinet. This would be the zone I'd try to stick to, anything above that line, because being such a deep cabinet, there's a lot of load on that. I've had a situation where I've installed IKEA cabinets, and to make it possible to fix to the wall that existed, I ended up having to put in a secondary rail, which, it ends up being quite a time-wasting process to try and do that. Whereas these cabinets are already structurally sound to be fixed that way. I think that's that. Actually, I might put a drawer together too so you can see that happening. Basically the same principles involved. Particularly if it's the first time you've assembled a drawer, it's worthwhile really getting an understanding of how all the parts go together. Again, all the uprights sit on top of the floor of the drawer. You have the drawer sides, the full length of the drawer, all assembled in that fashion. Nice gun part over here, the label on it. So that is a loose mock-up of how it would be assembled. But now, again, I'm right-handed. If you're left-handed, you may do things exactly opposite way around. Worth bearing in mind that the sides go onto the front and the back. Okay, so what I do is put the sides facing me like that. Now, the label side is the side that is basically the face of the cut. I didn't mention that earlier on the other assembly. With any process, there's a better side and a downgraded side, I should say. Frequently, they turn out good enough for both sides. But there's a preference to having, on a drawer, have the nicer side inside. Again, also with those cabinets, the same thing, the nicer side inside. Because later on the faces get put on which cover the outside of the cabinet and also the outside of the drawer. So okay, we've got front and back, which I'm putting that way. Nice side to my left. If you're left-handed, you do it the opposite way around. And the front, the sides here, sorry, these are the sides, that's front and back. The sides here, the nice side, or the face side, up. So when I grab the parts to assemble them, they will be oriented the way I'm going to nail them together. So the front and back here, and the sides this way. So I'm not likely to confuse how I assemble these parts. So I can fairly, I'm not going to say mindlessly because you've got to focus on what you're doing, but there's one less thing to worry about. And I'm out of bread. Now again, if you're screwing it together, the same principles with angling the screws outwards. Will apply these. Okay. I often, particularly if I've got many of the same size drawers, will just assemble a corner like that and produce a stack of corners. Just simply while I'm oriented doing the one way. Virtually any process where you've got any repetition of it, it's worthwhile doing the same process while your mind is set for it, while the tools are set for it, while the bench is set for it, whatever. So I would do, 20 of those, or whatever that was involved. Now once I've done all those parts, I bring them back as pairs and finish them off. And if you're really being pedantic, you could mark out the nail placement. You don't actually really see the brad holes or nail holes. Okay. So if you end up with one side nicely done and the other side's a bit wonky, put the bed of the sides, let's say they're both okay here, but let's say this is the nice side. I use that as my reference for the drawer bottom. So the drawer bottom, which all being well should be a little bit undersized. I did it deliberately. That is because of the way the runners work. Okay, now I've made that flush here and here. The process, make the side parallel to this edge of the bottom. Check both sides are the same. If there's any discrepancies, make adjustments. Okay. And there we have it, one assembly drawer. G'day, Michael here. I'm well and truly out of shot, I hope. I'm trying to show the detail of the actual joint. Now, one thing I need to impress upon people is the advantages and disadvantages of different joint techniques and what you need to watch out for. Now, obviously, I've usually used the brad gun. I don't know if you've seen any other videos, but if you have a look at that, you'll see me using the brad gun, which I'll demonstrate right now. The same rules apply in a lot of ways. The brad gun is very, very easy to use to assemble. The beautiful thing about using a brad gun is it's a very, very quick process, but also it does very little to change the alignment of the parts as you're holding them. The parts, as you can see there, are nicely flush. If I'm using a screwdriver to do the same job, I'll end up with, I'll just pre-drill to make it easy on myself. I'll explain some details later. There we go, run away. Very small parts are a little bit hard to hold. Normally I'd use a vise for this kind of work, but hey. Okay, so I'll do my best to hold it flush. But because the screwdriver is generating torsional pressure and also shaking around, it's much harder to hold things flush. So here we go. And I've taken good care, as you can see, but the product isn't flush anymore. Whereas the brad was beautifully flush. So it's fast and it's more accurate to use the brad gun. The disadvantage with having joints pre-machined is if you need to change something on site. Like I've often been caught on site when there was a spar pump put into a wardrobe which wasn't planned, or a air conditioning duct which wasn't planned. So having the parts with minimal work done to them, minimal holes cut out of them, minimal holes drilled, or metal parts inserted or so forth in the material, it's much better without any components in the parts for the cabinets. Alright, so I've done that one screw as my usual method. I'll show an easy trap to fall into. It's very, very tempting to just grab the screwdriver and the screw and drive the screw in. Now I'm going to do a very bad job deliberately. As you can see, things want to rattle around. They're there's a good chance that if you put it too close to the edge, you'll have the material breaking out. I don't know how well that shows up. Perhaps I'll put that in the background. You can see that the material is broken out there near the screw. Alright, so what did I do on the first screw that I didn't do on the second one? Let's grab a thin piece of material, just something to handle. If I draw a line to describe where the thickness of the board ends up, you can see that the first screw that I put in was very, very close to this line, so very much off centre. But it was also angled in an outward direction. There's a couple of reasons for that. One, of course, the material here is a lot more, there's a lot more of it, so it's a lot stronger than what we have here. But also, being angled outwards, if there's a likelihood of material delaminating, say, particularly with plywood or MDF, having the screw going at an angle outwards, I'll just draw that in roughly, you're going through various, I'm going to say, layers of material. So you're less likely to split them. If you were to go square through, this piece of material is more likely to split. Okay, so this is weaker on this part, but because also the screw would have gone squarely through, it's also more likely to split this part. So both parts are weakened by doing this. Whereas starting the screw towards the inside and angling it outwards produces a stronger part here and a stronger part against, splitting here. What I tend to do when I'm assembling the cabinets is, of course, do both. I use the brad gun, which again is towards the inside and angled slightly outwards. And I do that fairly quickly. And then the next thing I do, where I need to reinforce things, is put a screw in the same joint for where I need a higher tensile capacity. There we go. So the screw provides a lot of strength. It's very easy to underestimate how strong these brads actually are. Actually, just brad something together. We'll test the joint. Let's see if it makes a liar out of me. Okay, I've got two brads in there. There's a good chance, I'd say roughly 50-50 chance, of the brads pulling through this first part into the second. We'll see how we go. Oh, actually, one did, one didn't. So 50-50 chance was, made what I said true. Okay, but you can see how the ability of the brads to hold into this component is actually quite good. Now, the main reason for that is the brads are actually coated with a plastic coating, which in effect glues the brad in when they're fired in. The friction of the entry into the material produces a bonding. So the brads are actually glued in. When you consider that it's, no, I can show that, the head's been pulled through, see the shape of the head, has been pulled through this part, it's quite impressive. I was quite surprised when I first learned of that, 30 years ago, whatever. Alright, so disadvantage of screws. This is kind of marrying the best of both worlds. You've got the brad gun, which gives you speed and accuracy, but the screw providing strength wherever you need the extra bit of strength. Of course, you can pre-drill all the parts with a pilot hole. It is important, if you're going to pilot all the way through the material, I'll get into bits of material in a second, to make sure that the drill bit is a smaller diameter than the thread of the screws. There's one very flat battery. Alright, so I've piloted both parts together. I don't know whether you can see that. There's a hole in the second part, and of course there's a hole going through the first part. A good trick, don't know whether I can line this up well enough, I'll try. A good trick to find out whether the bit is too large, it's on the background, is if you hold the shank of the drill over the screw, you need to see thread either side. I don't know whether that's come up very clear, I'll try from perspective. Oh dear am I, are we? Can't see very well here. But the thread on the screws, oh dear am I. The thread on the screw is not sticking out far past the shank of the screw. The shank's the inner part of it. I'll grab a smaller drill bit. Forgive the shaking around here. But you can see the thread now sticks out either side of the shank of that drill bit. So this would be quite a good choice of drill bit for that purpose. Alright, I'd also change the battery. Alright, so I've changed the drill bit size down. And I've got a fresh battery in the drill. Now this time, because of the smaller diameter, the material doesn't clear so well from the drill. It gets caught more in the flute. But this does allow me to improve the precision of the assembly by holding the parts together. You can see that's nice and flush still. Hopefully the video is nice and clear. Okay, so I'll drive the screw in. And again, I've followed the same rule as I mentioned earlier, that the screw is started to kind of the inner limit of the thickness of the board and directed an outward angle, something like that. Giving us improved strength in this part, in this area, and also going diagonally through the layers of this second part. So it does increase the strength of the joint significantly. So if you want to take the time of piloting, making sure that the hole that you drill is not too large to screw the hole, you can make very, very nice flush joints. But it's a matter of, time versus effort and what you perceive is important to you. Perhaps for drawers this may be a very good method. Okay, so that's fairly flush, both in height and in width, quite nicely flush. And that was achieved by using that finer drill bit and using it as a pilot to go through both components. I'll just show that again. I'll just recap how that was established. As my chosen drill bit, I lined the shank up with the screw and making sure that the shank of the screw, the drill bit, is not larger than the shank of the screw. By holding one over the other, you can compare the two with your eyes. Very simply. I don't know whether that's clear enough. I hope that's clear enough. Okay, so that's how that was done. So you've got a strong joint, you've got a nicely aligned joint, and so you've got some precision and control with the joint method. But like I said, if you can afford a brad gun, if you do have a brad gun and get a little bit used to how it operates, you can save yourself a lot of time gaining the precision by simply braiding things together. Okay, maybe I'll grab another piece just to show that brad joint happening again. Now, these are very glamorous off-cut pieces. A little bit tricky to hold parts, as always. They're this small. Yeah, the brad is actually that little bit more accurate again than even piloting with the screw. Example here. Those are just offcuts, they don't be taken by the beauty. Alright, that's that. Now you can see how I've assembled the drawer. All the same principles. I've soldered the brad together. You could choose to screw it together to suit yourself. Alright, hope that was interesting and of value to you.